This lesson is about graphs. There's not a lot of examples to show because it's a primarily informational lesson. However, there will be some graphs to identify or to do on your homework. And I've got some notes in here about probably the easiest ways to go about that. So let's just get started here. And first of all, our previous lesson, we were looking at putting information in a table and doing frequency distributions and relative frequency distributions. And then we moved on to histograms. So the question becomes, should you use a graph or a table? So if you have a really small data set, you generally want to use a table. It just becomes too deceptive to use a graph if you've got a small data set. So if there's generally 20 values or less, use a table. If you have a really large set, a table's not inappropriate, it's fine. But if you put a large data set in a graph, that's when you can start to pick out some characteristics a little bit easier that help us describe the data set, including the distribution, kind of like we talked about with the histograms. So small data sets, definitely a table, but larger data sets, look for characteristics by making a graph. Our very first graph that we're looking at is a dot plot. A dot plot has to do with numbers, so it's quantitative data, and every single data value is plotted as a point. So that's one of the advantages to it. You don't lose any of your original data. You can still see exactly what the list of numbers is, but you can glance at it and see a shape, whereas when you're looking at just a huge list of numbers, you don't see that shape in the same way. So this lets us see the shape of the distribution, and you could recreate the original list of data values. Now, StatCrunch, I have notes on lots of slides down there at the bottom right about whether or not StatCrunch will do that for you, and I've kind of got a summary slide at the end. So StatCrunch definitely will create a dot plot. So in the same way that we've done it before, you can open it using StatCrunch if they give you a list. I mean, they might not always ask that you open something, but if you have an option to open it and you put it in StatCrunch, and then you go to Graph and choose that variable list to put in there and compute, it's going to show you a dot plot. So dot plot, you can see all of them, and this is an example of one. So we can see what most of them were because you can easily see what the tallest is. You can see that we kind of have outliers, those two dots that are spaced out away from everything else. And you can see that while it has some normal features, you know, we have that odd little short section in the middle right around here. But yet if I were to draw an outline, this would be somewhat normal. All right, so that's a dot plot. Now a stem plot, which and a lot of times it's called a stem and leaf plot, and it typically is called a stem and leaf, I think, in earlier grade school and stuff when you do it. We talk about the very first digit being the stem and the other digits being leaves, but it's a way of kind of taking numbers and just talking about their difference in those last digits, because we will have a lot of those first digits repeat. So like if you had, you know, 71, 72, 73, 73, 73, 76, something like that. You keep saying 70, so we just say, okay, in the 70s, and then we have all these last digits. And so what you do is you read the very first digit with the next number. Now, the 0 and 2 are separate. They're not the same. You only have one digit over here for the leaf, for this last part, so there's only one digit. Whereas you can see down here with the 10, you can put two digits in front for the stem. So this down here at the very bottom row would represent 102 and 104. Also notice that these long list of all these, what we would call leaves possibly out here, they're all in order. So you have all of the zeros and then the twos and then the fours, and that's an important feature of it. In fact, if you have to make one, if you were to type it in and you don't type them in order, it will mark things wrong because they are supposed to, all those leaves are supposed to be in order out there. But StatCrunch will make a stem plot for you. When you make a stem plot with technology, whether or not it's StatPlot or whether or not it's Excel or something else, a lot of times they actually end up displayed vertically like I have over here on the right, and I just turned that image, but that's because you can see that. Now sometimes they're still displayed this way, but when you want to talk about the shape of the distribution, Instead of thinking of a normal curve that goes up and then comes back down, you have to kind of turn your head sideways if you're going to do that, because what we're really looking at is that for a normal distribution on this, it would be short and then get long and then back short. So, you know, if you turned your head sideways, you could trace it and see that this one is a fairly normal distribution. Okay, again, you can see that shape there. So whether or not your technology displays it sideways so that you can easily see the distribution, or if it displays it horizontally and you need to turn your head, this is still something where we can look at our graph and see our distribution. Now, a time series graph. A time series graph has to do with quantitative data that's been collected at different points in time. And so what you're trying to really do with the time series graph is look at a trend. This is the sort of graph that it seems like they always show in cartoons behind the guy sitting in the office where they're talking about sales. But a time series graph is showing trends over time, and StatCrunch really does not do this one for you. What will happen though is that when you're doing your homework, you will have a chart. It'll list numbers like 1985, 90, it'll have those years, and then it'll have the numbers with them. And so it's not too hard for you to figure out if it's done correctly. They don't just give you the large, huge list of raw data for you to work with. So since it's already summarized, it's not too hard to make. But again, the time series, we're looking at different points in time to discover a trend. A Pareto chart is like a sorted bar chart. This is a fairly good example for a bar chart, but notice that it is sorted. We have things headed down as it goes. And a bar chart does not necessarily have those things sorted like that. But notice that it's about categories at the bottom. We don't have numbers. And that's also going to be true for a bar chart. This Pareto chart is a type of bar graph. You can see we have categories down here: jet ski, motorboat, utility, fishing, inboard, and sailboat. But a Pareto chart is sorted so that they decrease from left to right. So notice down here at the bottom, if you're doing a Pareto chart, if you want to use StatCrunch, you're going to choose a bar plot. But then you have to tell it to sort it, or put it in order. I can't remember if it said order or sort, but you have to tell it to sort it. A lot of people do like the Pareto chart because it just draws your attention to what's the most, what's the least, so that you can see those, and we see which categories then seem the most important to us at just a very quick glance. We could say, oh, these two right here, this is where people steal these boats. You know, those are the two. If you have a sailboat, people don't seem to steal it. Pie charts. This is a very common one, and it seems to me that a lot of people in general like to use these to display things. However, a lot of statistics and statistical analysis don't use as much because it just seems to use a lot of ink, but you don't have any of the real data there. You can't get the numbers out of that. So you can see the distribution, but we've lost all of our numbers. Now, occasionally you'll find bar charts where we have percentages or frequencies typed on there, and that is nicer. They're certainly eye-catching charts because, you know, they're compared to other ones. We've got some nice color on there. They also, it's just a little bit different shape than we're normally looking at all of our other charts. But again, they lose a lot of the data unless you add some extra things. So here we do have the same information we had in our other one, but we no longer know how many. And again, if we back up one, we can see the number of stolen boats, not just a comparison that jet skis are the most. Okay, so you have a little bit more data from a bar plot or Pareto chart. But anyway, I think this one is really then, it's kind of a proportion or percentage. So we might say, well, jet skis are 48%. But again, unless they label that, you can't actually see that. So the frequency polygon does look like a time series graph in that we've got dots with connected lines. However, it is not tracking a particular trend over time. So So what, instead of years at the bottom, we've got some other sort of a measurement. And it's similar to a histogram on the bottom axis, and that these numbers are continuous from wherever it starts. You would just think, even though the numbers aren't labeled, there is a continuous number line down here at the bottom that just keeps going. And that's going to happen on the frequency polygon. But instead of having those bars where we separated our categories with our class boundaries, lower bound and higher bound, what we're looking at here is the dot is above the class midpoint value. Okay, so we don't have a bar that shows the lower and the higher. We simply put a dot at the middle of that particular midpoint. We also can do, just like we did with histograms, we can do not only just one that shows frequency, but you can do a relative frequency, and you can turn this left-hand y-axis into percentages. But still, our dots would be above the class midpoint values. So when you see these connected dots, that's when you're going to have to, slow down and look at it, because it could easily be a frequency polygon, or it could be a time series graph. And just to kind of go back here, this is that time series graph. See how we have the years that go across the bottom? Okay, and that's always, and it wouldn't have to be years, but we've always got some measurement of the passage of time across the bottom in terms of months or years or days. It could say day 1, day 30, and then so on. But it's not just going to be a number line. It has something to do with the passage of time so that you can see trends over time. Now, a couple of problems that we sometimes have with graphs is that if they don't put a 0 on the left-hand side of the axis, it can exaggerate the difference. If you look at this very first graph, if you look really closely, you can see the values. You can see that this placebo, that bottom line is 10%. And then this next value up here is 12%, which means going across that placebo is probably right around 11%. And if this one, if OxyContin is at 23%, you can, if you're very, very careful, get those numbers and say, okay, this one's 23 and this one's 11. So that's really just OxyContin is a little more than twice as much. A little more than twice. However, when you look at this graph, this OxyContin column looks a lot more than twice as much as the placebo, because it is more than twice as tall. And that's because they started it at 10%. They did not start it at 0. If they had started it at 0, you would have a much more realistic picture, because just at a glance, we can see the placebo is about half of the OxyContin on the graph that's done like that. So you really want to look at your graphs and make sure that they started at 0 on that vertical axis. And if they don't, you need to very carefully read the numbers. However, I'm just pointing this out on your homework. If they don't start like that and they ask you about what the graph seems to communicate, they're saying just at that glance. So this one seems to communicate that OxyContin is about 5 times, 6 times, whoever knows. But it seems to communicate that. But in reality, when you look closely at the numbers, OxyContin is twice the placebo measurement. So beware of the non-zero vertical axis. Also, beware of pictographs. Pictographs is where they use pictures to try to show the difference between something. And that's not always a bad thing. However, a lot of people also like them, they'll use them in magazines or newspapers because they draw the eye there. They get somebody's attention. But they're often misleading, because if you look at these numbers again, if you look closely at the numbers presented, in 1970, it says 37% of adults smoked. In 2013, it was 18%. So it's about half. Even though this one, the width right here might be half of this one, this cigarette on the left is 4 times larger than that cigarette on the right. So it has to do with, this is a 2-dimensional figure. It has a length and a width. It's almost three-dimensional because we see that they're trying to show some depth to it, which would even be a bigger issue. But it's definitely two-dimensional, but yet they're only giving us one number. So you should never use two-dimensional or three-dimensional representations of something that is just one-dimensional data, because when you show these pictures, it's going both directions and it can definitely distort it. So those are your two things to really watch out for: the non-zero vertical axis and the pictographs. Now, before I do that last slide, let's just kind of go through one more time. If it's really small data, use a table if it's a small data set. Otherwise, if you can use a graph, you want to look for trends. So like we can look at distribution shapes. Dot plot uses dots, and we can get our values back out. Stem plots, we can get our values back out, and we can also see our shape. But instead of just using dots, we don't have to convert our values. Our values are right there for us to see them, and they are sorted in order. Do be aware that a stem plot might end up getting displayed the other direction. That's also true sometimes for the bar plots. Time series graph, it's going to have those connected dots, but it is showing a trend over time, and it's only tracking one thing. Notice this is only tracking law enforcement fatalities, but it's a trend over time, okay, of one thing. By comparison to that, a bar graph lets you see several different things because you have categories, okay? And you can see the frequency very much like a bar graph, but it is sorted. We have our categories, but it goes from greatest to least so that we can, at a glance, see which things matter the most to us. A pie chart loses all of the original data unless they go the extra mile and put some of the things on there, but it is proportional and it's eye-catching. So we have that proportion, and sometimes it's only, again, we can easily see what's the most, but we've lost all of our numbers, and so it's just not used quite as often with statistics. Frequency polygon, again, this is the one that looks kind of like the time series, but instead of tracking one thing over a period of time, we are dealing with the frequencies of an event, and we've got our continuous number line at the bottom, kind of like we did with the histograms. The dots are over the class midpoints, okay, over the class midpoints. And we can have a relative frequency polygon or just a frequency polygon. And then a couple of problems to watch for: the non-vertical axis and the pictographs, where they're using two or three-dimensional things for one-dimensional data. This is just a picture. You might just want to make a note of this. This is the drop-down menu from StatsCrunch. When you go into StatCrunch and you click Graph, it gives you a really long list. I actually cut it in half to paste it on here so you can see what will StatCrunch help you do. A bar plot, a pie chart, a generic chart, a histogram, stem and leaf, a box plot, down here a dot plot. It'll also do a scatter plot. So there are lots, and there's some of these we haven't even talked about, but this is our options for graphs in StatCrunch. So I thought that would be a helpful slide for you.